All right. So what we've gone over really in chapter 8 was we started looking at how to figure out like that margin of error and the rate. So it's like we know that this is going to appear somewhere within 2 standard deviations or whatever it happens to be. It's like we're within 5% of the mean and those type of things. That's one way to look at information. The other way that we can use that in the 5% or the 1% or the 95% or the 99% criteria is to look at figuring out if a claim is true. So back when I was going through school, through college, we had to do our like student teaching and all this other stuff. And when we had to do, before we actually did our student teaching, we had to basically be an intern at a school for a little while. So I was at a middle school, and Chips Ahoy came out with this contest where they, on their bags, it said every bag has 1,000 chips in it. That was their claim. So every bag of Chips Ahoy had 1,000 chips in it. And I'm like, middle school kids, they love to eat cookies. Let's do this. So as part of the contest, you had to try to prove their claim true. So we went through and we did experiments. I broke the kids up into different groups, and I gave them bags of Chips Ahoy, and I said, your goal is to figure out how many chips are in the bag. So kids came up with a whole variety of different ways to figure out how many chips are in the bag. One group decided that they were going to try to eat the chips, but not eat the cookies, but not the chips. It was fine. The winning one actually came out with they dunked the Chips Ahoy cookies in milk and melted the cookie away, then drank the milk and took the chips out. So we were able to figure out this. But along with this is why it connects to what we're doing tonight. It's like they're saying there's 1,000 chips in every bag, but not every single bag is going to have exactly 1,000 chips. That would be an average of all their bags. So some bags are going to have less, some bags are going to have a lot more. So it's like we're now taking a sample to try to figure that out. All right. So when we were looking at last week, when we were looking at chapter 8, we could figure out, it's like, okay, if I took my sample, I know my mean's here, and I'm 95% sure it's between here and here. So the question is, well, if 1,000 chips fall somewhere in there, do I accept that claim or do I reject that claim? So where would it have to fall before I would accept or reject that? And that's what hypothesis testing is. Okay. So when we're looking at hypothesis testing, we're going to say, okay, this is the claim that's made, and we're going to look at some data. And based on the data that I have, I'm going to be able to either accept that hypothesis or reject the hypothesis for something else. Okay. So with that, there's a few things that you have to understand before we actually go into the actual tests. That was loud. The first thing we're going to look at is vocabulary. That's all. We have 2 different types of hypotheses that we're going to look at. We have the null hypothesis. That's the hypothesis we're testing. Okay. So the symbol for that you're going to see is H with a little O underneath it. That's the null hypothesis. The alternate hypothesis, which will be H with an A, that's the hypothesis we're going to consider that's alternate to the null hypothesis. Okay. And then, of course, we have our test that we're going to actually do. So we have the null hypothesis and the alternate hypothesis. Don't worry, we're going to get to a lot more about what those are and how to pick them, because that's actually the key to the entire type of problem that we're going to look at. All right, so our null hypothesis, for what they're looking at, we're always going to look at it with a single variable, so basically, or a single parameter. We're going to use it as mean. So my null hypothesis will be mean is equal to whatever my sample mean is going to be. Or say my mean is going to be equal to this. That's my null hypothesis. That's the hypothesis that I'm trying to test. So for example, in the one that they gave you here, it says the mean weight of all bags of pretzels differ from the advertised weight of 454 grams. So my null hypothesis would be the mean is 454 grams. Or does not equal 454 grams because it differs from that. My alternate hypothesis. We have 3 different possibilities for alternate hypothesis. So if my null hypothesis was that the mean was equal to 459 grams, or grams, or my mean was equal to 454 grams, my null hypothesis could be one of 3 things. It could be either not equal to it, which means at that point it's a two-tailed test because we're going to look at both sides. We're just saying it's not equal to that mean, but it could be higher or lower. So that's how we would show that one, that the mean is not equal to whatever that number happens to be. That's my alternate. We also could do less than it or greater than it. So if the primary concern is deciding whether the population mean is less than a specific value, we say the alternate population mean is less than that number. And that would be a left-tailed test because we're looking at the left side of the bell curve. And if it's greater than, it would be a right-tailed test. We're going to look at the right side of that information. So remember how we were talking about last week? We're looking at the bell curve. We have the tails. The right, the left are both. That's in essence what we're looking at here. If it's a two-tailed, we're looking at both sides. So that 95%, we'd have half of it on either side. Okay. If it's a left tail or a right tail test, if we're looking at 95%, the whole 5% is going to be on that side. So that's why that matters which one you're looking at in that situation. All right. I'll tell you, yes, you can do all this in the world, but it doesn't mean anything unless you can actually apply it to the problems. And that's actually the biggest way to start doing this, is actually look at the problems and figure out your null hypothesis and your alternate hypothesis. So that's what we're going to look at first. Before we actually go start doing the tests, we're going to figure out what those pieces are. All right. So let's look at this one. This is the one we were just talking about. So a snack food company produces 454-gram bags of pretzels. You know the whole joke about if you buy a bag of potato chips, it's mostly air.
Not really a joke.
It's true. But the weight actually, and crazy part is the weight actually has changed. It's cut down. I always hate the fact that, like, you used to be able to go to the store and buy a half gallon of ice cream. You cannot buy a half gallon of ice cream anymore. They look the same size. They're not half gallon of ice cream anymore. They're almost down to almost a quart actually. It's like 1.25 quarts. Ridiculous. So did I tell you a story about the Walgreens when they changed the size of the tampon boxes? I worked at Walgreens when Tampax decided to. This was when the prices were going to go up. So they decided to change the number of tampons that were in their box, but keep the price the same, like everybody else is doing. Like coffee does, everything does. Like same with ice cream. Yeah, that's the one thing you don't screw with. Don't screw with that, because people like. I'm not female, so I have no clue. But from everything every female told me, yelled at me when this happened, was they buy it, they know exactly what they got, it's going to last this long, and when it didn't last that long, something was wrong. So, like literally a month later, after all the complaints and stuff, they came back out with a new box, but they didn't increase it. It says now it's 20% more, which brought it back to the original amount that was in there. But again, it was that design. It was like they were going through and shrinking things down to keep the price the same. So, and that's what a lot of things do. It's like the bag says the same, the pound of the coffee can looks the same, and everything else. There's just less in it, but the price doesn't change. So you don't think about it, because when you're buying the stuff, you really think about the price more than the actual how much is in the item. So when they make those claims that there's this much in the package, there has to be that much in the package or a reasonable range there. It might not have to be exactly that, but it has to be close. Okay. So they goes that the actual net weight deviates slightly from the 454 grams. It may vary from one bag to one bag, but the company insists that the mean net weight of all the bags is 454 grams. Starchist Tuna got in trouble for this too, because their cans of tuna did not have 5 ounces of tuna. They got sued for it.
You buy chips, you buy like half A or half.
Yeah, that's what it is.
How is it?
Yeah.
By weight, not by volume.
It's by weight, not by volume. Yeah,
Subway got sued pretty bad over something like this because it's the.
yeah, the foot longs weren't actually a foot long.
Long for 11 and a half inches.
Yeah, the foot longs are not a foot long. So it's like when they say things,
Or there's no $5
and that's the thing they do. They play games with it, so they don't have to necessarily raise the price. So, all right. So, as part of this program, as with anything, you have quality assurance. No, because if they check every single bag, they have to open up every single bag, and they place it. So they have to check a certain number of them to see if it's true. So, as part of this program, the Quality Assurance Department periodically performs a hypothesis test to determine whether the package receipt is working properly. That is to decide whether the mean net weight is 454 grams. So, what is the null hypothesis for this? So, what is that? Good. Yep. So my HO is what? Yep. My mean is 454 grams. That's my null hypothesis. A lot of times you can think of your null hypothesis as actually is what it should be. All right, this is what it should be. Now, what is my alternate hypothesis for this? Yes. Right. Why is it not equals and not less than or greater than ones? Not necessarily. No. That actually doesn't have to be that way. It depends on how it's worded. So they want to say, so they're basically saying you have to look at the question. So in this case, it was 454 grams is my mean net weight, right? So if it was 450 grams was my mean net weight, is that bad? It's not 454, so it's less, right? If it's 460, is that bad? Yes, it's not 454. So since either way would be bad, that's why it's not equal to. Okay? If we were only looking at the less than side of it, if we just wanted to make sure that it was a minimum of 454, then we would just look at the less than side. Okay? So, and that's really the question, how you have to figure that piece out. It's like, what would be bad? In this case, either direction would be bad. One would be bad for the customer, one would be bad for us. Yes.
These things have to do with the wording of the question.
Yeah.
So it's because the company is aiming for the exact 454. But if it was like worded differently, like this company claims that they have at least this amount.
Right. Then we can say it would be the other direction would be that. Or at most, yeah, if it was at least this amount, less than that would be the bad one. Yes. But if you think about it in this case, if you're the employer or the company, one way you'd be screwing your customers, which can get you in trouble, as we've just seen and talked about. And one way it's costing you more money. Either way, that machine needs to be fixed. Okay. So that's why my null hypothesis or my alternate hypothesis would be not equal to. All right. Is this a two-tailed, left-tailed, or right-tailed test? This is two-tailed. This is easy. Once you get the alternate hypothesis, it tells you the direction. If it's not equal, it's two-tailed. Less than's left, greater than's right. So that just kind of makes sense. So this is a two-tailed. All right. Oh, not that one. That one. All right. Take a minute. Come up with my null hypothesis and my alternate hypothesis for this one without looking at the question in the book because it gives you the answer. Or without at least looking at the answer in the book, I should say. This is a half century ago. The average U.S. woman in her 20s was 62.6 inches tall. Suppose we want to perform a hypothesis to decide whether today's women in their 20s are on average taller than such women were a half century ago. So what's my hypothesis or my null hypothesis? Yes. So that's my mean equals 62.6. What's my alternate hypothesis? Right. That's my alternate hypothesis, that it's greater than 62.6. So is this two-tailed, left-tailed, or right-tailed? This is a right tail. All right. So we've got the recommended adequate intake of calcium for adults is 1,000 milligrams per day. Suppose we want to perform a hypothesis test to decide whether the average adult with an income below the poverty level gets less than the required adequate intake of 1,000 milligrams. So what's my null hypothesis for this one? Yep. So this one's 1,000. And then my alternate hypothesis is I want to show that it's less than right? So that would mean this one is left.
Yes,
Well, the only thing I have to do next is actually prove it. Like, that's the only thing left we have to do. Yes. There's a whole bunch more sections in the section. No, they actually, by the way they're doing it, it's always equal to. Yes. Yeah. So in essence, so once we start to actually prove them, you're going to understand why that's the case. If you were doing this in reality and like actually doing more higher in statistics and stuff like that, your null hypothesis can actually be less than, greater than, or not equal, those type of things. But for simplicity's sake, we're setting it equal. So, and your alternate hypothesis is basically what you're trying to show could be true. So. All right. Yes, I kind of did this separate. That's okay. All right, so Step one, the easy part. Find me my null hypothesis and my alternate hypothesis.
All right, what page is this on?
This is section 9.2. What's the page? 376. It's not even half of what my number is because I'm at 694. Like I can't even say it's halfway because it's not even that. Yeah, I jumped sections. All right, so what's my null hypothesis? $275 yards. That's what Jack tells Gene that his average drive of golf balls is 274. So that's the null hypothesis. What's the alternate hypothesis? So Gene tests it and she gets 264.4, right? So she's saying that his mean is less than 275. So sometimes you got to look at what's going on to figure out, well, what's the alternate hypothesis of this? So what could be going on? So in this case, it's going to be less than it, which means this is a what tail test? A left. We're looking at a left tail test. Okay. All right. So the next question is, what's the logic of the test? So what am I trying to show? So we've got two different options, right? We have our null hypothesis and we have our alternate hypothesis. If the null hypothesis is true, Jack's average drive of his golf ball is approximately 275. It's not going to be exactly 275 because we don't know it is exact. But we can come up, again, within that range. And they're asking a 5% significance level. So within 5%, or so 95% accuracy, he's within 275. If the alternate hypothesis is true, that would mean it's outside of that 5%. It's outside of that 95% accuracy, right? So then Gene is right in that Jack really doesn't shoot that high. And if you know anybody who plays golf, that's the alternate hypothesis is probably true because they always say they shoot better than they actually do. It's like the same thing with fishermen. You always catch a bigger fish than you actually do. So it's the way it works. All right. So that's the way our hypothesis test is going to go. Now, let's actually do it. All right. So to do my hypothesis test, we need to figure out so we have our mean. That's the 275. And then we have to figure out our standard deviation. So this is of the sample. So let's figure out my standard deviation, which was my standard deviation divided by the square root of however many I have, right? So I think in this problem we said our, did it tell me in there? Wait, I think it does. I think it was just down a little bit further on the thing. Yeah, it's 20 yards. I just scrolled up a little bit for it. All right, so my standard deviation was 20 yards. And we did 25 shots? 25 shots. So my standard deviation of the sample is 4. All right, so we've got that, right? All right, so let's figure out our z-score, the test statistic for it. So that is, my z-score was the formula for it. It was mean minus the mean divided by the standard deviation. So it's the mean of that minus that divided by that. So I have x minus the 275 over 4. So we're not going to plug a number in there yet. We will in a second. So we wanted a 5% statistic, right? There was this question was looking for a 5%. Okay. So 5% on a left tail test is going to be what z-score? You need your z-score table. So it's going to be on the minus side, and we're looking for what? We're looking for 5%. So 0.05. So negative 1.65. Did everybody find that? Okay. So, yeah. So we look at our z table, and we're looking for 0.05. So we're going to go down. So that's 0.054837261005, and then 495. So remember, I always said error on the side of the smaller one, not the bigger one. So that's how I get the negative 1.65. Yeah, I'll write on it. Give me a second. No. That's why I'm going to write on it. Okay. Give me back my slide. Really? Okay. All right. So here's my Z table. I don't have any more copies of it. It's if you have the book, very back of the book. Or if you don't, if you have your phone, you can literally just search. It's literally it's right there. I like, or do what I just did and search Z table on Google. All right, so we're looking for in this table here, 0. So we're right here. Oh, and I shared back on that one. Now there we go. We're right there. So I said always err on the side of the smaller, not the bigger. So we're looking at that one right there, which means we're at 1.65. And that's how I get the negative 1.65. Questions on that now? Are we good with that? That was basically what you were doing in chapter 7, I think. Might have been 6. It was chapter 6 and 7. It was that test. I knew it wasn't that one. I couldn't remember which chapter it was. So yeah, that's we're looking for that. Oh, that's right. Chapter 7 was more of the T stuff. All right. So I've got my the computer just does not want to do what I want it to do today. All right. So we've got our Z, our 5% should be at Z equals negative 1.65. Notice, I did not cut that in half like I did on some of the stuff last week in chapter 8. Because in this case, it's a one-tailed test, so the 5% is the full 5%. If it was a two-tailed test, I would cut it in half to do the 2.5. All right, but since it's one-tailed, it's the full 5%. All right, so now we're going to plug in to see what our Z-score really is. So we're going to do what we just did here, except now we're going to put in, what was it, 264.4. So 264.4 minus 275 over 4. And this ends up equaling what is it? Negative 2.65. All right, so the question is, so I wanted my Z-score to be negative 1.65, and my Z-score ended up being negative 2.65. So the question is, do I accept or reject the null hypothesis? So I haven't told you that yet. When we're looking at what we're going to do, and I really should have done this differently, so I'm going to actually redo the slide. When you're trying to decide if you think about what we did last week, okay, 5% would be 2 standard deviations below, well, not quite 2 standard deviations below, right? So if I did the 275 and I subtract 2 standard deviations away from it, we'll just round it off to the 2. That's taking away 8, right? And I'm now at 267. And he's still worse than that, right? So I know that mean is not within my 2 standard deviations. Okay? So, and 2 standard deviations is 95%. Correct? That was 95% accuracy. So I was 95% sure that it's going to be between 267 and so forth, so on and so forth. And I know it's not within that, so he's probably wrong. And that's in essence what we're looking at. So if it falls outside of whatever my Z-score was, so in this case, the Z-score was negative 1.65, or they just cut it in the middle and did 6.445. So it was down here. We're rejecting his claim. We're saying he's wrong, and that his score is probably lower, because that was my alternative hypothesis, that it was going to be lower than the 275. So my alternate hypothesis has been proven not true, but, and that's really the big thing when you're actually making the claim, you can't claim that the alternate hypothesis is true. All you can claim is that the actual hypothesis was false. Okay, so you're rejecting the null hypothesis in favor of the alternate hypothesis, but we don't know the exact value. Okay, we just know it's not what he said it was. Does that make sense? Yes? No? Huh?
Yeah.
So it's like, and in essence, if you think about it, it's not much different than what we did in the chapter 8 stuff. Where we're looking for that error range. We're just now, instead of looking for the error range, we're testing whatever their claim was. Okay. All right. Okay. So when we're looking at these claims, the 5% significance level is one that's used quite often. You'll see 5%, you'll see 1%. Those would be the ones that are used most often. If it's a two-tailed test, those are typically the z-scores you're going to see. And notice the z-score doesn't matter what we were looking at, right? The z-score is the z-score. That's irrelevant of the data. So if you want to write these down somewhere, that saves you a step. It's kind of like last week when I was telling you chapter 8. If you have a 95% confidence level, right? It was negative 1.96 to 1.96. That's always true for a 95% confidence level. You're now seeing that right here too. That's the 5% significance level, right? That's 5% on the outside. It's the opposite of what we were basically talking about last week. The left tail and the right tail, those were, if you remember and wrote those down last week, those are your 90% significant or confidence level. Because if you took 90, that's 5 on either side. So it's negative 1.645 if it's a left tail test, and 1.645 if it's a right tail test. So that's your 5% significance level. So did I make it any harder by adding that one extra step? Well, yes, I made it a little harder, but is it drastically harder? Okay, and I think it's very similar to what we're doing in chapter 8. So it's not, and from what I gathered from most of you last week was you guys seem to have gotten that, or it made sense. So this is very similar to that. Let's all right. So there's two different ways that we can look at this. Okay. What we just did here is known as the critical value test. Okay. Where you were looking for the z-score and comparing it to the z-score. There's also what's known as the p-value test, which is very similar. The only difference is instead of looking at the z-score, we're looking at the actual percent. So if we went back to my z table here, and we got, what was it, negative 2.65, right? So let's look at negative 2.65. It's right there. So it's 0.0040, right? Is 0.0040 less than 0.05 or greater than 0.05? So So I had 0.0040, and that's less than, was it? Yeah, 0.05, right? So my P is percent, is less than my significance level, which is 5%. So I reject. The critical value, I compared the 2.65 to the negative 1.64 for 5, which I also reject. So they're both the exact same thing. All the concepts are the same thing. It's just a matter of what number are we comparing. Okay? So one of those, we're looking to find the critical value number and comparing the z-score to it. One of them, we just get the z-score for the data that I have and I compare it to the percent. Okay? They're both the exact same thing. They both do the exact same work. You can do either one for every single test. It just depends on which way you want to think about it. Okay? So why I'm telling you this is because the way the book did it, 9.2 is the critical value way, 9.3 is the p-value way. I just taught you both of them. So I'm not going to do a whole bunch more examples of it because it's literally the same thing. So it's like, you don't need to do a bunch of either one of them. So does that make sense? How they can use either one of those compared works? You can use either one, yeah. It just depends on how you want to look at your table, basically. So I don't really care how you do it. It makes no difference. They're going to come out to be the same way at the end. So, all right. Let's look at some problems now. Problems. All right. Let's go back to the height of women. All right. So in this actual problem, they gave you a table of all the heights. Well, 25 of them, and they wanted you to find out the mean and all this other stuff. I decided I wasn't going to make you do that. I just gave it to you. All right. So here's what I want you to do. Step 1, find me my null hypothesis and my alternate hypothesis. So do that part first. This should be in, if you're looking at the book, this should be in section 9.4. It was the first example. It was example 9.7. No, sorry, not 9.7. 9.11. There you go.
Yeah, it's on 361.
I told you, I basically skipped all of section 9.3. They spent a lot of time going over a lot of stuff that doesn't even take that long to go over. That's why when I looked at chapter 9, I'm like, I could do this in 1 week, no problem. It's not even 7 o'clock yet.
That's why I think
Yeah, but like it's not even 7 o'clock yet. And for all intents and purposes, I've taught you everything I need to teach you. This is literally all we're going to do. It's do some hypothesis testing now. We'll do some z-score ones and some t-score ones. All right, so what's my null hypothesis? So my mean is equal to 62.6. And my alternate hypothesis is, what am I trying to show in this case? It's greater than. So that my mean is greater than 62.6. And what's the significance level I'm looking at? 1%. Okay. All right. So we now basically have to figure out my z-score, right? Okay. So so I need to find, so I know my mean of my data was, I gave that to you, is down here at 64.24. I have my sample mean was 62.6. And now I need my standard deviation of the sample was going to be, what was it? 2.88 divided by the square root of, how many did we do? 25. So 2.88 divided by 4. 0.72. Oh no, that's not right. I divided it by 4, not 5. What's 2.88 divided by 5? Yeah, I did it by 4 instead of 5. 0.576, so 0.58. Okay. All right, so my z-score is 64.24 minus 62.6 over 0.58. So I've got 2.83. Yes? No? Think I calculated it right? I did use a calculator. But I could have typed numbers in wrong. 288 or 2.88 divided by 5. Because it was the standard deviation, which they told us was 2.88 right there, divided by the square root of the sample, which was 25. Are we good to that point? Yes. Huh? Well, yeah, now you got to do one of the two things, right? I'm either going to look for the z-score for 1% or look for this on the z-score table. Either way works. So now it's the matter of you go doing the critical value or the p-value. So I will show you both. So p-value, I'm on, my number's got to be greater than 1%. So greater than 0.01. And my critical value, whatever number they get, the number there has to be greater than the 2.83. Okay, so let's go to my z-score table. So I need to go to the positive side. What was the number? 2.83? 3. .83. Yeah, it was 2.827, so 2.83. All right, so 2.83. So I think it's 0, right? 0, 1, 2, 3. Gives me 0.9977. So what was it? 0.9977. Okay. So my p-score, my yeah, my p-value is actually 0.00 0.23. So I reject. Because that's not greater than 0.01. Okay. Questions on how I did the p-value? So I just found the z-score that I just found, which is the 2.83. So 2.80123 is right there. Oh, as I'm on the wrong tab now. 2.83 was 0.9977. And remember, on the right side, we're going to 1, right? So I have to subtract off to find the actual number there. Now, if I'm looking for the critical value, I'm looking for the z-score that's going to give me 1%. So in this case, it's going to be 0.99. So I got 2.3, 1, 2, 3. So 2.33 will give me 0.99. Because this is 0, 1, 2, 3. So 0.99. So it's 2.33. And that means I also reject. So the critical value, you're looking for 1%. The p-value, you're looking for whatever your z-score was. I'm going to compare that to the 1%. Either one's going to come out the same. What's wrong and why you're shaking your head? What step are you messed up on?
This table makes
Thank you.
sense.
Okay,
Can I ask you one question?
sure.
I'm on the positive, Z,
Yep,
2.8, right?
yep.
3,
0.99767, which is 0.9977. Mine just only went to 3 decimal places.
okay. And I noticed that yours had it twice in a row. It had the 997, and I saw some of them that are double the same.
Yeah, because the
number.
numbers, it's the rounding errors. It's just rounding.
Okay.
Does anybody have?
That just throwing me off.
Yeah.
I'm like,
Does anybody have a Z table that I can borrow? Yeah. Oh, here. There you go.
Thank you.
Does anybody have one a Z table I can borrow for a bit?
Yeah, I
I'm just because I'm going to put it up here and I'm actually going to use yours.
in the back of my book.
Okay, then let me borrow it.
Yeah, I was just throwing you off. I'm not getting that same number.
Back we can. Because then I can actually use your table. Like, it might be easier.
Yep, so in the book one matches what you have up there.
Yeah, because it's because it's just a Google search.
Yep, got it.
All right. Okay. So on your Z table, we've got 2 sides. We've got the negative side and the positive side. Okay. They're going to do. Okay. So remember when we're looking at our bell curve, we're always looking from the left side to the right, right? So the left side is 0, the right side is 100, or 0 to 1. What you're looking at is a decimal, okay? So the negative sides are always going to be all the numbers from 0 to 0.5. The positive side will be 0.5 to 1, or the 0.99999 keeps going up. You can look at either side of the table. All right. For hypothesis testing, it's going to be easier to look at the correct side because you're trying to compare numbers. So you want to look necessarily at the right side. So in the problem that we just looked at, we were looking for, at first, we were looking at for 2.83. A little more. All right, so 2.83. So I'm going to look on this side of the table. This is going to give you the number before the decimal point, the standard deviation, and 1 decimal point after. So 2.8 is right here. Okay? I now look at the top, and it's going to give me the second decimal number. Okay? So 2.8 and 3 is right here. So in this, and the paper that I passed out was 0.99767. I think in the book it says 0.9977. Notice it's the exact same thing, it's just rounded different. Okay? Either one will work for your calculation, it's not going to change it.
So that's the.
So that is your p-value, correct. Okay? So your p-value, P stands for percent. Okay? And these are percentages. Okay? So we're now ahead of 99.99767% of all the values. Okay? So that's my p-value. When we were looking at that, I'm going to switch back over to here. That's my p-value. Notice I subtracted it from 1 to compare. Okay? You also could have just compared it to 0.99 if you wanted to. It would just be the opposite direction, it would have been less than. So, but I think it's easier to just, because we're on that side, subtracting it from the 1 to get it. So it's 0.0023 is not greater than 0.01. So I'm rejecting my claim. Okay. Does that make sense? Huh? Okay. That's P. All right, we good? Does that make sense now or no?
Sure.
That's not a good answer. Which step? Like, I've got tons of time today, literally. I'm basically done. So, considering this is actually the most important part for chapter 6, 7, 8, and 9, is understanding how to use this table. Let's spend some time making sure you get it.
I think I just don't understand what like, how do I know which side you
So in this case, it depends on, in this case, I was looking for 2.83. That was the z-score I got. So that's what I'm looking for. Okay, so on your table, you have positive, negative, right? I'm looking for positive 2.83.
Okay.
On the last problem that we did, so in this problem, I was looking for a negative 2.65. So if we go over to the negative side, negative 2.6, 5, 0.0040. Okay? Yes. The calculation, the z-squared, the formula. I'll go back and show you in a second. So for this one, I was at 2.65. That's where I'm looking here. And that's the number that I got. And since that was, in this problem, was less than 0.5 or 0.05, which is what I was comparing it to, I reject it. Okay? This formula right here. That's my z-score formula. That's why I said, this is like, out of all the stuff, this is basically everything we've done for the past 3 weeks. It's all the same concept for all intents and purposes. It's just using those numbers differently to determine what we want to talk about. Yes. This is a different problem. This was the other problem. That's 2.83. So that's, okay, one step at a time. Are we good with the p-value?
You're going ahead of you.
No, that's right. Are we good with how I found the p-value?
Yes.
Okay. So, if you're good with that way, do it that way.
I'm not going to walk this way.
Okay? If you're good with that way, do that way.
I'm staying with you.
Okay. It just depends on the direction you want to go. So, the critical value, we still needed to do the 2.83. No matter what, we still needed to get that number. The only difference is this one, instead of looking at for the 2.83, I'm looking for 1%. So when I go back to the table, on the positive side, I'm in essence looking for, since I'm on the positive side, 0.99. So I look in the middle here for 0.99, and I get it right here, which is 2.33. That's why the 2.33 came. Huh? Yeah, I go for the one that's closest to 0.99. So that's the closest one to 0.99. And that's the number I'm comparing it to. So since my z-score is bigger than that, than the 2.33, I reject the claim. Because I wanted it less than that. Okay? So notice, same, it just, you're going to use the table either way. It depends on how you want to use the table. Do you want to use the table to get the percent? Or do you want to use the table to find the percent and get the number?
I just like half thinking. Is that the way?
That's okay, because it was the Zoom call. She said that.
Is that the way that we to find it, like, during time?
Yes.
That's the way.
Yes. So if I was looking for 95%, I would go to
I
here
think that's why I'm so confused.
and go, okay, here's 95%. That's 1.65.
I think that's why I'm so confused.
Okay.
It's because I'm trying to do it that way.
Yes.
And then now you're trying to teach me this.
And that's what I'm saying. Either way works. So it just depends on how you want to use the table. Both things can be found on the table. So whichever way you want to use it best, use it that direction. Okay, because they come out to be the same way both times. Right? Which is why I'm taking all this time to go through and do this, because it is the most important part of this whole lesson. All right. Any other questions with that? Before I give you another problem to try on your own. We're not going home yet. Everybody at my house will be happy if I'm already home, but I'm like,
Right, I can shopping. I still gotta go get a hair.
we'll be out of here before we will be out of here before 8 o'clock. Don't worry.
Okay.
All right, I think I got 2 more problems I'm gonna do.
If we compromise to one.
You guys just don't complicate your life. Sorry.
Yeah, I'm gonna have to rewatch this like 3 times at home.
All right,
Don't we all?
No.
I have 2 problems listed left. See, 1, 2, and then we're done.
Fine,
I won't even do the. I'll even skip the T ones that I was gonna do. No. Actually, I don't know if I did. I might have actually. No, I did not.
Okay, we can skip it. Great. Let's go.
Screw the two.
All right.
Not necessary.
Not necessary.
All right. Find me my answer.
Fine.
Oh, yeah, that's, yeah, say it like that. Property.
So find me my pieces. The null hypothesis, the alternate hypothesis, the mean, standard deviation, and z-score. Find those. Basically, those 5 things is what you need to find. And then we'll do our test.
Repeat that again.
Null hypothesis, alternate hypothesis. So find those 2 things. And then to find your z-score, you need your mean, you need your standard deviation, and you need the test mean, the sample mean, which is the big numbers down the bottom. You guys are doing that. I will end up. Save me time in a little bit. Yeah. This is why I have to use Grammarly to write my phone.
Yeah.
I'm really not that great at grammar.
Grammar? I love it.
This is why basically my boss is not a math person. She's an English person. She's learning the math, but she hires us to do the math. She's checking the grammar. Yeah.
I'll take two. I thought that's the first one.
Can I like where we're at.
It's also going to be on my website tomorrow morning. So.
Oh, I printed perfect stuff. I know.
All right.
So the answers will be up on there.
Maybe not tomorrow morning, but they will be.
Is it gonna like show the breakdown of the work? though?
Yeah. That's how I do my answers. I do it out. I literally just scan my work.
Oh, okay.
Everybody's got the information down, right? So I can actually start doing it. And there's less than that. Okay. So my sample mean is 947.4. 1,000. Is 1.88. Point 1.8. All right. My null hypothesis was 1,000. Was the mean is 1,000. My alternate hypothesis, they were asking to show that people who are below the poverty is less than that, is less than the 1,000. So my alternate hypothesis is the mean is less than 1,000. The sample mean I had was 947.4. The mean of all the samples is 1,000 because that's what we used. The standard deviation was the 188 because that's what they gave us for the standard deviation, divided by the square root of 18 because that was the number of people that I looked at. So I got 44.3. So this stuff right here, actually all the way down to here, except for the null hypothesis part, this stuff all right here was exactly what we were doing in chapter 8. And for the most part in chapter 6, actually. The only difference is we were done at that point. So we were just looking for the z-score in chapter 6. So we did this formula here. In chapter 8, we were looking for the sample means. So we were doing basically all of this. So very similar stuff. Now, I got negative 1.18 is my z-score. So I look at my table.
187. So within 1.1.
All right, 1.19, sorry. Okay. It's not going to change my bed drastically. You're right. That'd be 1.19 by rounding. So if I look at my z-score table, I go to negative 1.19, and I'll change my number. So it's 1170 instead of 1190. Negative 1.19. And you also can tell this by looking at your alternate hypothesis. If it was less than, it's going to be a left tail test, so you're on the negative side. If it's greater than, you're on the right side, so you're looking at the positive side. So, but the z-score will also tell you that it's negative, so you're looking on the negative side. Yes. Good.
Alright, another example we did before. When we got to the first one, is less than what we change it. Yeah.
This. So your goal is remember this.
Yes.
Okay. We're thinking about this. So this was negative, what was it, 0.05, so that's negative 0.05. My 11.7 is over here. Therefore, it fails. I mean, I'm not rejecting my own null hypothesis because it's over this section here. That's in essence what you're doing. You're just trying to figure out which side of that line it's on. Since it's on this side, I'm not rejecting. So the other thing we were looking at is it's always opposite of the way of the piece, because in essence, if it's down here, that's less than my number there, and that's not what I wanted. I'm going to reject it if it's less than.
Okay.
So you can't always go back to that picture and go, which sides of the line is on? And that'll give you the direction. So you don't necessarily have to look at the less than or greater than sides. So in this case, I don't have you can say this a couple different ways. You can either say I accept the null hypothesis that the mean is approximately 1,000 no matter what, or I do not have enough evidence to reject the null hypothesis with this thing. So they could, if they get me more data and stuff like that, it might change, but the data they gave did not show that it was significantly different. So in chapter 8, I would have said that I'm 90% sure that my mean is 1,000. So based on that data. So. All right. One more. Since I cut the information out, so in this one, they actually had the actual data chart had one number that was like, it was an outlier. So that's why if you look here, it says the sample for 35 cheetahs, and I only did on 34 cheetahs because I eliminated the outlier. So when you're doing your calculations, you're doing it based on 34 cheetahs, not 35 cheetahs. I don't think this one also didn't give you your z-score. Hold on a second. I got to give you one more piece of information. There, you go. That's the other piece of information. 5% and the standard deviation is 3.2. And then we're done and you can go home and start enjoying your Thanksgiving. Except for most of you are probably having to work the next couple days.
On Saturday.
Oh, jeez.
Oh, that's terrible.
Have to work.
I have to work every day this week, except for Thursday.
Well, at least they gave you Thursday off.
Every night. I've got 2 jobs, so I have Wednesday off from the one job.
And Thursday, we're feeding the homeless in London, so we'll be there practically 8 in the morning. It's for 2 to 6.
So that's a good thing. I know it's a long day and I know it's like, but that's a really nice thing to do. I do that typically on Christmas. Because we do all the stuff on Christmas, normally Christmas Eve. So on Christmas Day, we'll go out. I work in a soup kitchen sometimes. Or one year I was an elf at a children's event. We were giving out toys and everything else. So it's like I always try to do something for Christmas.
I told my friends that my daughter dropped my grandchildren off, because I want them to see what it's like to be.
Absolutely. No, I think that's a very,
So they're all serving the homeless. on
Good.
Thanksgiving.
that's very good.
So they can appreciate their iPhones.
Absolutely.
And their parents who paid that money for it.
Absolutely. It's one of the things I think a lot of people don't understand. It's like we have a lot more stuff than even the poor among us really aren't poor if you go to other places in the world. So four. Unfortunately, 5%. So it's. All right, so what do we got? Are we accepting or rejecting?
You lost me at two.
Yes, treat us up to chills. Now, so what would be the only change that I'd have to make in this? Instead of looking for 5%, what am I looking for? Right, that's the only change. Okay. So what was my z-score? Before we did all that, what was the z-score? Because none of that changed. That is correct. So what percent does negative 0.86 show up to on your z-score? Look at your table, go to negative 0.8, and then go over to the 6.06 column. Good. Is that bigger than 2.5 or 0.25 or 0.025? Yes, it's yes. The 2.5%, so 0.025. So I'm accepting the null hypothesis because it's within the main part of the bell curve. It's not in the wings. It's not in the tails. I would have to reject it. It would have to be less than 0.25 or 0.025 or greater than 97.975. It would have to be in the wings. It's somewhere in the middle. So we cannot accept, or we cannot reject the null hypothesis. Okay, that's it. You just have to practice it. And the thing about it is, again, it's the same thing we did in chapter 8. All right, there really is all the steps are exactly the same until the very end where you're trying to make your conclusion. Like the whole Z table, the Z score, everything, all that is exactly the same. So we came up with this whole thing all the way down to here, with that exact same thing. And as long as it was within the 95%, we're good. So that's what we did. Okay. All right. Enjoy Thanksgiving. Your practice is your project is due Monday, and the test is on Monday.
Are you trying to tell me a break?
Yes. I wanted to give you it. I could push it, but then I'm not going to give you a week for review for the final. And I really wanted to give you an entire class period for 3 hours, 2 hours, whatever it is, to review for the final exam.
Yes.
So it's that's why the test is next week. Have a good Thanksgiving. I'll see you next week. I'll still be around my computer, so if you need help, just email me.
Email you.
Yes, I am 21.
Okay,
I'm way
you
over
drink?
21. Huh?
You drink it all?
Not really. Why?
Because I was gonna give you a cider for Thanksgiving.
I like
It's I tried it last weekend at a place up in Springfield. It was on tap. They had it with cinnamon and brown sugar on the rim of the glass.
Oh, cool.
Very pleasant. So I
I'll
figured
try. I'll try.
I'd share it.
I'm twice 21. I'm 45.
Okay.
Thank you very much. I appreciate it. Have a wonderful Thanksgiving. Yes, and I left them at home. I had to score though. Hold on. Let me end this. Let's stop recording. Nope, don't want to end the call yet. I got to stop the recording.
You already told me the score, right?
Huh?
You already told me.
Yes.